This is the second half of the 4.1 chain rule notes. So this is the warm-up for today. Please go ahead and put your video on pause and do the best that you can to complete this warm-up. When you're ready to check the solution, go ahead and unpause the video. So for this question, it says determine the points at which the graph of the following function has a horizontal tangent line. Remember that a horizontal tangent line comes from finding the points where the derivative would equal 0, because the derivative is equal to 0 wherever the graph has a flat part. So if I want to find the derivative using the quotient rule, I would say that u is equal to x squared minus 3, v is equal to x squared plus 1, the derivative of u is equal to 2x, the derivative of v is equal to 2x. If I multiply backwards first, I get 2x times x squared minus 1, x squared plus 1, minus, multiplying forwards, 2x times x squared minus 3, all over x squared plus 1 quantity squared. So if I simplify the numerator a little bit, I get 2x cubed plus 2x minus 2x cubed plus 6x, all over x squared plus 1 quantity squared. My 2x cubes are going to add to 0, and I get 8x over x squared plus 1, quantity squared. Now, horizontal tangent lines, again, are where the derivative is equal to 0. So if I want to know where this equals 0, I am concerned with where the numerator is equal to 0. So I want to know where 8x equals 0, which is at x equals 0, if I divide 8 on both sides. So this is the x value. I know it's not a point. If I wanted to figure it out, I could plug it back in again. If I plug in 0 to the function, I get 0 squared minus 3 over 0 squared plus 1. So that would be negative 3 over 1, which is just negative 3. So the point is actually at 0 comma negative 3. But the x value is more my concern. All right, let's get started. Today we're looking at the chain rule. So this is section 4.1, a continuation of what we did yesterday. We left off on this problem yesterday, and this part of the problem is what we, in period 2 at least, if you're in period 3 we already did this, but in period 2 at least we left off on this problem and we said that we could continue to be factored, so I wanted to just show you really quickly how it could continue to be factored. So let me write down where we left off and then I'll show you how it factors. If you look in your notes from yesterday, this is where we left off, and we said that it has a GCF. So if you look really closely at both of these two groupings, the first one has a 2 and the second one has a 2, so I know that that's part of the GCF. The first grouping has an x and the second grouping has an x, so I know that's part of the GCF. And the third grouping has a 2x minus 3, and the second grouping also has a 2x minus 3. And in fact, they have multiples, so I can pull out up to 3 of them. So 2x minus 3 cubed. With that GCF, I can write it in the front as I factor, so I get 2x times 2x minus 3 cubed. And I'm left with, if I look at this first grouping, I'll just start to cross stuff off that we can get rid of. If I look at the first grouping, the 2's divide out to be 1, the x's divide out to be 1, and I can get rid of 3 of the factors in the top with all 3 of those in the bottom, and I'm left with 1 of those factors of 2x minus 3. In the second grouping, 8 divided by 2 would be 4, so I'm left with a 4 from the second grouping, plus 4. The x's, I can divide out 1 of the x's, so I'm left with 1x from the second grouping as well. And then all of the 2x minus 3's are going to divide out. If we simplify down here, we get 2x times 2x minus 3 cubed. And then if we simplify inside of these parentheses, 2x plus 4x would be 6x minus 3. And then we found out that this still has another GCF, and it's not that we missed it earlier necessarily, it's just that it only appeared at this point now that we combined our two groupings together. So 6x minus 3 has another GCF of 3. If I pull out that GCF, I can move this 3 out front, so I would have 2 times 3 to be 6x times 2x minus 3 cubed, and then the 3 that I factored out of here would leave us with 2x minus 1. And that is as simple as it gets and as factored as it gets. All right, in third period, again, I think we already did this problem and put the problem solution up on the board. You might not have had time to copy it down yet, so I'm going to give you a minute to pause the video and try this problem. Take a few minutes. If you get stuck, you can watch the video, or when you get a final answer, you can watch the video to check to see if you got it correct. So pause the video now and finish number 12 or try number 12 if you haven't done it yet. All right, so here's the solution to number 12. I'll let you take a minute to look through it. Essentially, we had to do the quotient rule and the chain rule. We started with the chain rule. We started with the inside and outside functions. And in the middle of taking the derivative of the inside function, we realized that we needed the quotient rule. So from here, I went up to this little bubble up here and did the quotient rule, simplified as much as possible, and got this answer. Then continued back down with the chain rule again, finding the derivative of the outside, multiplying them together, and coming up with this as a final answer. So go ahead and pause the video if you need to write that down or check where you made a mistake. All right, today we're going to look at trig functions, so using the chain rule with trig functions. And there's the main thing with these ones is making sure that you understand how to write it correctly so that you can recognize the inside of the function versus the outside of the function. So for example, for this first example, I would rewrite this, and I'm hoping that you guys are aware of this, but I have seen some errors from students in the past that maybe you're not aware of what this means. So I want to make sure you understand the difference between this first one and this second one down here right below it on the placement of the two and what they mean. In this first one, this is sine of x squared, and they write the 2 here because if you write the 2 at the end, some people get confused and think that this means that you're writing sine of x squared, the quantity x squared. So this I want you to think of as sine of x quantity squared, versus this one I want you to think of as sine of the quantity x squared. So notice the difference between how you would see it written on a test or a quiz and what it actually means. And please pay attention, pay close attention to what it actually means to do. So for this first one up here, the inside function is sine of x. The outside function is I squared. If I'm taking the derivative of the inside function, the derivative of sine of x is cosine of x, and the derivative of the outside function is 2i. And if I replace that with what I is equal to, that would be 2 times sine of x. Now, chain rule says to multiply the derivative of the outside times the derivative of the inside. Therefore, y prime is equal to 2 sine of x times cosine of x. Final answer. For the second one down here right below it, we have the inside is equal to x squared. The outside is equal to sine of the inside. The derivative of the inside, I prime, is equal to 2x. The derivative of the outside would be equal to cosine of the inside. And if I replace that, that would be cosine of x squared. Again, the chain rule says to multiply the derivative of the outside times the derivative of the inside. So therefore, y prime is equal to 2x cosine of x squared. And no, you are not allowed to combine these x's together. Remember that cosine is a possessive function, so this x squared belongs to the cosine. You're not allowed to combine it with this extra x out front. By the way, if we're going too fast here, please feel free to pause the video at any moment in time to kind of recap what we've done and go back and listen again if you need to. And if you still have questions about what we've done, you can ask me when I come back tomorrow. All right, for this one over here, again, I want to make sure that you understand that this is sine of x to the power of 1/2. So when I set up my chain rule, I have the inside is equal to sine of x. The outside is equal to I to the 1/2. I prime, the derivative of the inside, would be cosine of x. O prime, the derivative of I to the 1/2, would be 1/2 I to the negative 1/2. From here, if I rewrite it, I get 1 over 2 radical I. Remember that the negative means I can push it back to the bottom of the equation again. And the, All right, so from there, we rewrote it. The negative exponent pushed it to the bottom, and we rewrote it as a radical. And then if I want to write it one more time with the I actually in there, it would be 1 over 2 square root of sine of x. Chain rule says to multiply the derivative of the outside times the derivative of the inside. So if I do that, and I don't think there's much we can simplify, we would get y prime equals cosine of x from the derivative of the inside divided by 2 radical sine of x from the derivative of the outside. Final answer. For this one, we have sine of x to the 1/2. My inside function is equal to x to the 1/2. My outside function is equal to sine of the inside. I prime is equal to 1/2 x to the negative 1/2, which can be rewritten as 1 over 2 radical x. And O prime would be cosine of the inside, or in other words, cosine of the square root of x. Oh, that's ugly. Try that again. Cosine of the square root of x. Once again, chain rule says to multiply the derivative of the outside times the derivative of the inside. So that would be y prime equals cosine of the square root of x over 2 radical x. Again, the cosine radical x is the derivative of the outside, and the 1 over 2 radical x comes from the derivative of the inside. And just as a reminder, cosine is a possessive function, so this radical x on the top and this radical x on the bottom are not able to be simplified because this radical x belongs to the cosine. So you have to leave it like that. That's your final answer. Take a minute to pause if you need to copy any of this work down. All right, so we're going to work on these ones, and we're going to do 2 of them together, and then you guys will do some on your own. And notice that these ones have multiple layers to them. So you're actually going to be introduced to an inside, a middle, and an outside in these problems. So I'm going to erase these 2 over here for just a minute so we have some extra room. We're going to do these 2 together, and then you guys can go back and do those other 2 as you try on your own. So for this, I'm going to rewrite it. The first thing I'm going to do is I'm going to rewrite this as sine to the power of 2x to the 1/2. And then I want you to realize that, remember, we can rewrite this. Sine to the power of 2x is the same thing as sine of x quantity squared. And that whole thing is raised to the power of 1/2. Well, if you know anything about properties of exponents, then I hope that you know that 2 times 1/2 is equal to 1. So that would just be sine of x to the first power, which is just sine of x. When I take the derivative of that, I get y prime is equal to the derivative of sine of x, which is cosine of x. So that one, even though maybe it looked a little bit complicated, is actually fairly easy when you look at how it simplifies. By the way, they don't do that too often on the AP test, because that would be way too easy of a question if you could rewrite it. You will see, however, things much more like that next example down below. So if I rewrite this one, I get sine of x squared to the power of 1/2. Now notice that I can actually add in like an extra set of parentheses right here. And here's where we start to get into this whole concept of the inside, the middle, and the outside. So if I asked you what the inside was, you might say that the inside is sine of x squared. But then inside of that, there's actually another inside. This x squared is inside of that even. So we're going to have 3 layers. We're going to have an inside, which is x squared. We're going to have a middle, which is sine of x squared. And we're going to have an outside, which is sine of x squared to the power of 1/2. So let me set these 3 things up. We have the inside to be x squared. We have the middle to be sine of the inside. Notice that I'm using I for inside. And then we have the outside to be the middle to the power of 1/2. And I'm using m for middle. If I look for my derivatives, I have I prime is equal to 2x. O prime is equal to cosine of I. And if I rewrite that with I in replacement, I would have cosine of the inside, so cosine of x squared. And then O prime, oh, that wasn't supposed to be O prime, was it? Let me fix that. That was supposed to be m prime, the middle. O prime, the derivative of the outside, would be 1/2 m to the negative 1/2, which, remember, we can write as 1 over 2 radical m. And if I replace m with what it's equal to, I would have 1 over 2 square root of the middle, which is sine of I, and I is x squared, so that's sine of x squared. So, now that we have 3 layers, the chain rule dictates that we multiply all 3 of them together. So y prime would be equal to the derivative of the outside, 1 over 2 square root of sine of x squared, times the derivative of the middle, which is cosine of x squared, times the derivative of the outside, the inside, which is 2x. There's not a ton that simplifies. I think the only thing that I can see that simplifies is this 2 and that 2. Other than that, everything else will just be written right next to each other. So y prime is equal to, there's an x in the top, there's a cosine of x squared in the top. In the bottom, there is a square root of sine of x squared. And I don't think anything after that would simplify much. So that's how you do it with an inside, a middle, and an outside when you rewrite it. So why don't you guys go ahead and try these two problems. Put the video on pause and rewrite them first, and then go ahead and try to find the derivatives. When you're ready to push play and watch the solutions, then go ahead and do that. Alright, so here are the answers to both of these problems. For the first one, I rewrote it, so this square root of x you can rewrite as x to the 1/2, and then don't forget when you have this squared here, it means the whole thing is being squared. So, again, the squared here means that the whole thing is being squared. So we have an inside, which is x to the 1/2, I set that up here. We have the middle, which is sine of the inside, I set that up right here. And we have the outside, which is the whole thing being squared, so the middle being squared. The derivative of x to the 1/2 you can see is right here, 1 over 2 radical x. The derivative of sine of I, cosine of I, just replaced it with the inside. And the derivative of m squared would be 2m, and then again just replaced m with what it equaled. We multiplied all three of these layers together. So we have the derivative of the outside, the derivative of the middle, times the derivative of the inside. The only thing that simplified was our 2's. 2 divided by 2 happened to be 1. Other than that, we had to keep everything written exactly the same. For the second example, it was one of those trick ones where it might look more complicated than it actually is. If I rewrite this, this would be the square root of x squared to be rewritten as x squared to the power of 1/2. Remember that 2 times 1/2 is equal to 1, so this is just sine x to the first power, and the derivative of sine of x is cosine of x. So that was one of the easy ones that simplified nicely when we rewrote it. Let's look at some more examples. Alright, we have 4 examples here, and I think, if I remember correctly, this is our last slide. So we'll go ahead and finish these 4 examples, and we'll be done for today. So we have 3 examples here. Alright, so we're going to do 2 of these together, and then I want you guys to do 2 of them on your own. The ones that we're going to do together are the first one and the last one, and then you guys are going to do the other 2 on your own. So let me erase the rest just to get us started with extra room. Alright, if I rewrite this, it would be 6 times cosine of x squared, and then this whole thing is squared. Notice that the 6 does not become a part of it, it's just this that's being squared. If I set up my chain rule, I have the inside to be x squared. The middle is cosine of the inside, and the outside is 6 times the middle squared. When I find my derivatives, I prime would be 2x, m prime would be negative sine of x, and o prime would be 12m. Oops, this should be a sine of I. If I replace the I, it would be negative sine of x squared. If I replace the m, it would be 12 times cosine of x squared. Chain rule says to multiply these together. When I do so, I get negative 2 times 12, that's 24, x sine of x squared, cosine of x squared. Final answer. Go ahead and put that on pause as you write it down, and then unpause it when you're ready to move on to the next example we're going to do together. Alright, so for this one, I'm just going to rewrite it like this. So I'm going to rewrite it with parentheses like that. And I want you to notice that this is actually a product rule problem. If you read it, you say 4 times secant of 3x times tangent of 3x. So the fact that we have a function of x times another function of x means that we're going to need to use the chain rule. So instead of starting with the chain rule, or it means we have to use the product rule, but instead of starting with the chain rule, we're actually going to start with the product rule. So I'm going to do all the work up here if that's okay with you guys. So I'm going to say u is equal to the first function, that's 4 times secant, secant of 3x. V is equal to the second function, that's tangent of 3x. U prime is equal to the derivative of u, so that's 4 times the derivative of secant, and I'm actually going to do the chain rule here in out loud, so hopefully you're able to pay attention in that way and follow along. If you need more help clarifying, just let me know tomorrow when I return. The derivative of secant is secant tangent. So it would be secant of the inside times tangent of the inside. All right, times, that's the derivative of the outside, so this is O prime. Let me write that there. This is O prime, the derivative of the outside, times the derivative of the inside, and the derivative of the inside was 3x, so the derivative of that is 3, and that is I prime. All right, so that's U. V prime is equal to the derivative of the outside, which would be the derivative of tangent, is secant squared of the inside. So secant squared of 3x, that's the derivative of the outside, that's O prime, times the derivative of the inside, which is just 3. So again, this is the derivative of the outside, this is the derivative of the inside, I prime. If you need to set up the chain rule, go ahead and set it up as you guys are working. All right, so remember product rule says to multiply the derivative of the first times the second. That's the ones I just highlighted. So y prime is equal to, if you look closely at what simplifies here, we have 4 times 3, that's 12. We have tangent of 3x here and tangent of 3x here. So I can rewrite that as tangent squared. And we also have this secant. So we have secant of 3x times tangent squared of 3x. Product rule says to add these two things together, so we're going to do plus, and then what I highlighted in orange, the derivative of the second times the first. So again, if we look closely, we have a 4 here and a 3 here, that would be 12. We have secant of 3x here, and we have secant squared of 3x here. Since this is the same, we can say that this is secant cubed. Secant cubed of 3x. If they wanted to factor, which they very well could, both of these groupings have a 12 in them. Both of them have a secant. All right, so we can pull out a 12, we can pull out a secant of 3x. And that leaves us with, from the first one, the 12 is gone, the secant is gone, that leaves us with tangent squared of 3x plus, from the second one, the 12 is gone, one of the secants is gone, and we're left with 2 secants, so secant squared of 3x. Again, on a free response, both of these would be accepted as correct, but I have a feeling they would write their multiple choice answer like this second one. So that would be how you would write the second one. All right, so go ahead and take a minute and make sure that you can follow along with that and copy everything down from that. When you're done, I'm going to give you 2 problems for you guys to try on your own. Alright, so we just did this first one and this last one. I want you guys to put the video on pause and try these other 2 problems. Alright, for this first one, I rewrote it like this. I said this is tangent of 5x to the 1/2. The inside function would be 5x, the middle function would be I to the 1/2, and the outside function would be tangent of the middle. The derivative of 5x was 5, the derivative of I to the 1/2 was 1/2 I to the negative 1/2. Sorry, I didn't write it, but I did it. That should be a negative. Negative 1/2. So that's 1 over 2 radical I. Replace the I with what it equaled, so that's 1 over 2 radical 5x. The derivative of tangent is secant squared, so secant squared of the middle, which turned into secant squared of 5x to the 1/2, which we have here. Chain rule says to multiply these 3 things together. So I'm paying attention to what's in the numerator versus what's in the denominator. So we have a 5 that's in the numerator, we have a secant squared of 5x to the 1/2 that's in the numerator, and that's where this comes from. There's the 5, there's the secant squared of, I just rewrote the 1/2 as a radical 5x. And then in the denominator we have this, 2 radical 5x from the derivative of the middle. And that's where we got that. Remember that the radical 5x's cannot simplify since secant is a possessive function. It possesses that radical 5x and that stays alone. 5 and 2 doesn't simplify either, so that's the final answer. Alright, if you're not done with that second example yet, go ahead and push pause again and we'll finish that second example right now. Alright, so for this one, we rewrote this as secant of 2x plus 1, the whole thing quantity cubed. Therefore, the inside is 2x plus 1, wrote that here. The middle is secant of the inside, wrote that here. And the outside would be that whole thing, or the middle, cubed, wrote that here. The derivative of 2x plus 1 is just 2. The derivative of secant is secant tangent, and I would just replace the i's with what I was equal to, so secant of 2x plus 1, tangent of 2x plus 1. The derivative of m cubed was 3m squared, and so if I replace m with what it equals, it would be 3 times secant of 2x plus 1 quantity squared. Chain rule says to multiply the derivative of the inside times the derivative of the middle times the derivative of the outside. When we do that, I'm looking for things I'm able to actually combine. The 2 and the 3 here can multiply to make 6. Then I have 2 secants of 2x plus 1 here, so I have secant squared of 2x plus 1. And here I have another one, secant of 2x plus 1. So I combined those together, since they're the same, to get 3 of them, secant cubed of 2x plus 1. And last but not least, the tangent kind of stayed by itself at the very end, tangent of 2x plus 1. So that was our final answer, not able to be simplified. That's the end of today's notes. Go ahead and finish up there, and then whatever questions you have, you can ask me tomorrow.